Start, sir. Good afternoon, students. So today I am taking class for BSc third semester. So in the last class we have studied variable separable method. Okay, so this is a method for solving a first order and first degree differential equation. So now we solve some problems on this differential equation. So first, that is solve e raised to y plus 1 cos x dx plus e raised to y sin x dy. Okay, so to solve this problem, first what we do, we make variable separable. We make variable separable means we collect x dx one side and y dy another side. So let us see how to do this. Okay, so now what I do is I divide throughout by divide the whole equation by, now see here, cos x term is there and x term is also there, but this we don't want, okay, because this is a y term and it should come here. And similarly here, this sin e raised to y and dy, they are one side, but sin x we don't want, so we should move this sin x to here. Okay, so for that what we do, we divide the whole equation by e raised to y plus 1 into sin x. Okay, so then what we get, this is e raised to y plus 1 cos x, this we divide by e raised to y plus 1 into sin x. Next here e raised to y sin x dy, and here we divide again by the same thing, e raised to y plus 1, okay, sin x. Now in this case, this e raised to y plus 1 get cancelled, and here it is sin x and sin x get cancelled. Okay, so now it becomes cos x by sin x dx. So cos x by sin x is what? Cos x by sin x, already we know that is cot x. Okay, so this becomes cot x plus here e raised to y divided by e raised to y plus 1 dy is equal to 0, and here it is also is equal to 0, and this is equal to 0. So now here, see here, this cot x dx, now all terms, cot x terms and dx we have collected at one side, and all y term and dy term we have collected other side. Okay, so now integrating the whole equation. So integration of cot x is, what is integration of cot x? It is nothing but integration of cot x is cos x by sin x, that is cot x. When you integrate it, it gives log sin x plus, and here again it is e raised to y by e raised to y plus 1. Its integration is log of e raised to y plus 1. By using substitution method, put e raised to y plus 1 as t, then e raised to y dy becomes dt. So dt divided by t. So integration of dt by t is nothing but log t. So t means e raised to y plus 1. So e raised to y, log of e raised to y plus 1 plus integration constant, that is c. So this is the solution of the problem. Okay. Okay, next we solve another problem on this equation. Second one, solve xy dy by dx is equal to y plus 2. Okay, now this is the problem. So now we do here, what we do is we collect y dy term one side and x dx other side. So what we do, we divide throughout by x into y plus 2. So divide by x into y plus 2. So what you will get? So this is xy, okay, dy by dx, all divided by, this will be divided by x into y plus 2 is equal to y plus 2, again this will be divided by x into y plus 2. So now here x get cancelled, and here y plus 2 get cancelled. So now what I do, I write this as y dy by y plus 2 is equal to, now dx I cross multiply to this side, it gives dx by x. Already 1 by x is there. I cross multiply this dx here, so it gives dx by x. So now here y by y plus 2 I have to integrate this equation. So okay, so now what I do is I apply partial fraction method. I apply partial fraction method. So just you know that how to apply partial fraction method. So put y by y plus 2 is equal to a divided by y plus 2. Okay, a divided by y plus, or otherwise you can do one way. Another thing is that y divided by y plus 2 here. After differentiating this equation, you can do one thing: add and subtract 2. Okay, so here I will add 2, then subtract 2, so value does not change. Okay, dy is equal to dx by x, right? The value does not change. Add and subtract 2. So next I split this equation. What I do, y plus 2 divided by y plus 2 minus 2 divided by y plus 2 dy is equal to dx by x. Now this y plus 2 get cancelled, and it becomes 1 minus, this is 2 by y plus 2 dy, or it is dx by dx. So now we integrating. So after integrating, integration of dy is y minus 2 as it is. Again integration of dy by y plus 2 as we did in the last case. Put y plus 2 as t, dy becomes dt. So integration is log of y plus 2 is equal to integration of dx by x is log x plus integration constant c. So this is the solution of the given problem. Thank you. Good.